Build Show Network. Steve Basic Architect. We're out here at our Build Show, Build Boston site. And this week, I thought we would talk a little bit about roof framing. Now, because this house has a flat roof and we have a consistent 24-inch overhang that wants to turn the corner here, we had to do some, I'll call it fancy framing. It's not real crazy, but there had to be some thought put into it because maintaining that 24-inch overhang is a little bit of a challenge, right? If we said we just wanted 24 inches on, say, the side of the house, it would be real easy to take these floor joists, fly them out, extend them out to 24 inches like they are there, and build the soffit. But the minute we choose to take that soffit and turn the corner, it means we also have to develop the same cantilever relationship out the front of the house here. But that also makes this corner become something special. So how do we solve for that? Well, the first thing you'll notice is our common roof joists here, they fly out, they make up that soffit to this beam. That beam is about 4 feet inward, so it's basically 2 times the outside overhang, right? So 66% of the cantilever is inboard. We have this large beam, it extends all the way across the house here. That gives us the ability to change the direction of the framing. So you'll see here, inside that beam, we actually go out the corner with a single LVL, that's a 9.5-inch LVL. That flies all the way out to where that soffit turns the corner. What that does is that cantilever beam now provides us the opportunity to continue these overhangs out over that, but it also allows us then to turn 90 degrees and provide these overhangs out this side, out over that soffit. And then you'll see here that the minute we get beyond where that LVL is attached here, then we can switch back to our I-joist. Those are rotated 90 degrees from our other I-joist, and those basically fly out and make that 2-foot overhang there. But that allows us to turn that corner. Now, one of the things that helps out is the fact that Simpson strong tie, when we have that 45-degree angle, we need to have some type of hanger system that these can come into. So you can see here that it actually makes a skewed 45-degree hanger. So we could put that on that 45, but our rafters now are perpendicular or parallel to the original roof joists that are going out there, but they can attach to that outrigger that's at that 45-degree angle. Let's go back to the studio. We've got a beautiful roof framing plan. All of this stuff is outlined there. We can jump down, get Big Red out, we'll walk through that framing plan, and we'll have a little bit more discussion on how we solve for having that 24-inch overhang turn the corner. So I'll see you back at the studio.
Hey everybody, so we're in out of the rain. We're here at the studio. We got some pretty cool drawings illustrating that framing at the corner of that roof. Always a challenge. Sometimes you come up with what you think are really cool ideas, and then, all right, now we have to figure out how we actually build it. So it's always the challenge. But we got Big Red in hand today. We got the details. We got it figured out. Let's share that info.
All right, so I grabbed a partial view of the roof framing plan. So this is where we have that flat roof or I-joist framing. You can see this is the extent of the roof here, outlined there. You can see these are the walls below. We have a window there, that's that corner window that goes to there, and then of course wall below here. And I'm drawing that in because it's important to understand, this is that corner that we were talking about there. We also have the opposite hand version here. So the basic idea is we have to get that continuous soffit to turn the corner so that this dimension D equals that dimension D. And in this case here, D is probably roughly about 22 inches. So by the time we build it out, we're at that 24-inch overhang. But we need to make those consistent. And you can see if I just ran all of my roof rafters like that, I would get to the wall here and I would have no way of solving for this area here. So I need to be able to bring that stuff back into the structure. And so the way you do it is the mastermind behind that detail is this LVL that goes out as a hip jack, or I don't know what you would actually call it. But it basically rests on the wall here. This area here, well, that's a cantilever, right? Because it's basically flying out. And then this gets tied back to some type of structure. So you can see our rafters here are moving and spanning in that direction. So we actually had to change the direction to this, because just like that hip jack, we have our standard or common rafter here on the short side, where we also have that cantilever there, as well as the space that goes back. Now, for cantilevers, usually the rule of thumb is the cantilever equals L over 3. Right? So if this is roughly 22 inches, let's say 2 feet, then that means this dimension, if that's L over 3 or 1/3 the length, this needs to be 2/3 the length. So at 2 feet, this needs to be 4 feet. And you can see there, it comes back, roughly that 4 foot 3.5 from the face of the wall. So we have our 4 foot, we have our 2 foot, we're meeting our rule of thumb here, and we did get it all engineered, so those numbers can move slightly. I've done projects where they both have gotten cheated a little, but those have to come in, you see here, all the way across. Well, we have one large beam here, because the change of direction means all of these common rafters now, they're all floating in air here until I put a beam in there to connect them. And you can see there we called out 3 9.5 inch deep LVLs. And so we solve for those common rafters, L over 3, 4 foot, 2 foot, we get our cantilever, but as we come around the corner and now want to turn it, we have to bring that jack back. And that is also an LVL that you saw there. And then we have our full length rafters there, but then we have little jack rafters here that come back, and those get attached in those hangers. And those are that skewed hanger that I showed you. But basically, by doing that on that 45, it means that each of these rafters get immediately mirrored on the outside, and then we have some filler in here to grab the plywood. Yeah, you can see we actually doubled up the band there just to stiffen that corner too, where we actually have a double rough fascia on the outside there. See, those are all called out as 9.5 inch deep LVL joist too. So this whole corner area here is basically all LVLs that are tying back into that main beam. And so that now that cantilever, equidistant, 22 inches for D around the corner here, so we can maintain that look all the way around the perimeter of our structure, and we get a nice consistent dimension there. and then structurally we go out and grab that. We bring everything back to this carrying jack rafter, which brings it back to the beam at that location and that location, and then that load gets brought back that way, and some of it goes this way. Likewise here, some of it goes that way, some of it goes that way, and then it gets picked up by a post underneath the beam there in the wall. And so that's how we maintain that beautiful 22-inch overhang around the corner and all of the components that we use to make it so.
Well, there you have it. Shared info. If you're looking for more shared info, it's the Basic Architect on Instagram, posting stuff up there all the time. Got a few projects going on that are really interesting, so we're tossing up info left and right. So go check it out. If you're still looking for more, you get the Build Show Network. We got literally thousands of videos on there. My library, which you should watch 7 times, Science says, and all of my colleagues. Go check them out. Mechanical Hub, Drywall Shorty, Jake, Wade, all of them. They all are putting up some really, really good stuff. If you're still looking for more, Unbuild It Podcast, every other week, Jake, Peter, and I get together on YouTube, and we talk through something building. So it's always a treat, too. We have fun doing what we're doing there. So go check it out. Enjoy. Until next time, long live our buildings.